Okay, hello, my name is Simon Good. I'm here to present the work of the OSCE TAC. So this element of CMEMS is provided by a project team who goes by the name of Wind, Ice and Temperature at the Surface, or WITS. So within this talk, I'm going to be talking first about CMEMS and the OSCE TAC, the role of WITS and the OSCE TAC within it, and then I'm going to go through the WITS products with particular focus, given this is Global Ocean Week, on the global coverage products that we provide. So and that includes SST products, sea ice products, and wind products. And then I'm going to focus in on the reprocessed products that give us long time series of consistently processed data, and give a couple of examples of applications of those products. And finally, then just finishing off with some further information, how you can contact us and access the data. So this is probably familiar to most of you, but the CMEMS production elements are split into the MFCs, which are model-based, and the observation-based thematic assembly centres, or TACs. And there's 4 of those, and the SST, sea ice and wind data are provided by the Ocean and Sea Ice TAC, or OSCE TAC. So this came up at the end of one of the previous talks. So we're a satellite-based TAC, so 3 of the TACs are based mainly on satellite observations, with the in situ TAC working with the in situ observations. Slightly unusually, I guess, we're covering 3 science themes in one. So we've got SST, sea ice, and surface winds. We're providing global and regional products, products that are aimed at the regions represented by the MFCs. We have near real-time products that are delivered within typically a day or even within a few hours of the data being collected, and reprocessed products that cover longer time periods with a consistent processing scheme. We've got an awful lot of products, over 30 products, which is quite a sizable chunk of the total number that is given by CMEMS. And a lot of those products have below them a number of different data sets. So, for example, for the sea surface temperature data that I'm responsible for, we have not only the SSTs themselves, but also monthly, daily SSTs, but also monthly means and seasonal means. And that gives over 100 data sets that are accessible through the CMEMS catalogue. And as might be guessed by the mentioning the regional products earlier, our closest users we think of as the MFCs, who use the data for assimilation and validation. So I mentioned before the Wind, Ice and Temperature, the Sea Surface Consortium. So these are the members of the team. So we have 10 different institutions represented. And later on I'll show how that divides up between the different products that we provide. This is quite a long list of the WITS products. So obviously this is quite small writing, so I'm not expecting you to read through all the list now. There'll be a bit easier to digest display of these in a little while. But you can see from the names that they cover the 3 different areas: the sea ice, SST and wind. There's the regional products like the Arctic here and GLOW for global. We have 2 different processing levels, level 4 and level 3. So I'm going to explain what those mean in a minute. We have near real time and reprocessed. And then the end of the names here are the fact that they're observation-based products and the codes for each individual product. So what do I mean by when I say satellite product levels? So these range from 0 to 4, and as you go to a high level of processing, the level number increases. Within CMEMS, we provide level 3 and level 4 data, but for completeness, I'll just quickly explain the lower level ones. So level 0 are the unprocessed data that come from the satellite. At level 1, the data have been pre-processed, so they are still at full resolution, but they've been calibrated and geolocated, but you haven't yet got the geophysical parameter that you're after, and that's what happens at level 2. But again, they're still on the satellite projection. To go to level 3, the level 2 data are then aggregated or projected onto a spatial grid, and sometimes you can also they also have data from several instruments and platforms combined together. And level 4 is when you do an analysis of the data, for example, to fill in gaps due to cloud. And this just represents that visually. So on the left here, we can see a plot of some level 2 data. It's presented as a strip, which is how the satellite would have viewed the surface of the Earth as it went round its orbit, and you get longitudes and latitudes associated with those. And then to go up to level 3, we project those onto a more familiar latitude-longitude grid, or whatever grid you want to use. And you can see here the path the satellite took as it went through its orbit. So that was a single orbit of data. What we can do is combine together multiple orbits of data to make what we call a level 3C file, or a level 3 collated file. And you can see as you get more and more orbits of data together, you get a more complete picture of the Earth. But there's gaps in the data. This is sea surface temperature from an infrared instrument aboard a satellite, so it can't see through clouds. So wherever there's a cloud, there's some processing being done to work out that there's a cloud there and the data's missing. So that was level 3C. You can also go further and produce an L3S file, which is a super collated file where you combine together data from multiple different instruments. But even then, you've still got gaps due to clouds. And to get over that, you can do a level 4 analysis, which interpolates between those gaps to produce a complete field. So this is the display of products I mentioned earlier that was a bit easier to understand. So we've got tables here for the different product groups. We've got SST, sea ice, and wind, and then also separated by regional coverage, so global, Arctic, etc. So SST, we've got the most coverage in terms of different regional products. Across the columns, we've got near real-time level 3 data, near real-time level 4 data, and also reprocessed data. And as I said at the beginning of this talk, I'm going to be focusing on the global and the reprocessed products. And we've actually got quite good coverage for global, in terms we've got SST, sea ice, and global data at, in most cases, level 3, level 4, and reprocessed. It's just the sea ice level 3 that we don't have. And of course, you can find all these products by going to the Copernicus CMEMS website and accessing the online catalogue. And you can use the search on the left to drill down to find the products, or use the product numbers that I displayed earlier and just look here at this display do a search. You can find the product that you want. So now I'm just going to go through each of the different global products in turn, and also give a bit of guidance about when you might want to use one or the other, because we do have level 3 and level 4 and reprocessed available. So for SST, level 3 data, as I already said, have holes in them due to cloud. These are nighttime equivalent SSTs, or foundation SST. So in a moment, I will explain a bit more about what that means, foundation SST. So, but bear with me for a minute. So these are daily products on a fixed geographical grid. There's not been any smoothing or interpolation applied. And there's information on the sensor that the data came from and the original time and location of the input data. So I guess what it comes down to is, with using the level 3 data, you've got a good idea about where the data's come from. With the level 4 analysis, so there's been an interpolation of process applied, so there's no holes in there. There's a foundation product. We also have a skin SST product, and again I'll explain that in a moment. And according to whether you choose the global product or the regional ones we have, there's different resolutions and setups. And you get an uncertainty estimate with each SST value, but you can't understand normally where the SSTs came from. You can't easily trace back to the original satellite SSTs. So the GRIS project, with the Group for High Resolution SST, some time ago defined different types of sea surface temperature that you might see depending on how deep in the surface you go. And obviously, close to the surface, you have a diurnal signal in the data, which is shown here. But if you go deep enough, you get to a point where roughly speaking, it's free of variability, which is one way of thinking about the foundation temperature. The other way that you might think about it is there's a point each day where near the sunrise, when this temperature at the surface starts to increase, and this is shown in this plot, which is also from the GRIS website, and you can see that the different colour lines are different depths in the surface, and just before dawn, the temperatures all collapse to a single point, and then the diurnal cycle starts. That's another way to think about the foundation SST. So, but the products themselves look like this. So this is our level 3 product. It's a level 3S product, so super collated. It's on a 0.1 degree grid. It's a daily foundation SST running from 2010. The plot here was produced for a recent day. You can see the gaps due to clouds. If I show you now the level 4 equivalent to that, you can see the difference between level 3 and level 4. All the gaps in the clouds have been filled in. And this is a product we produce at the MetOffice, which is often known as OSTI, the Operational Sea Surface Temperature and Ice Analysis. It's on a 20th degree grid. It's a daily foundation SST from 2007, but there's a reprocessed version of this available. Another product that's provided on a global grid is the GRIS Model Multi-Product Ensemble. This takes level 4 analyses produced at different centres around the world, and they each get put onto the same quarter degree grid, and there's median and standard deviations of those analyses provided, and also anomalies and gradients, which is the plot shown on the right here. So that's a really useful product if you want to compare the different analyses in use around the world, and I could also give some information on where the analyses are a bit more uncertain than in other places. This comes in daily and ran from 2009. One of our newest products is a skin SST. So this is showing the diurnal cycle in the skin SSTs, and they're supposed to, the data points represent hourly average data. This is showing the difference between the foundation SST and the skin SST throughout the day in February this year. And you can see the highest values moving across the globe, corresponding to where the solar heating was. This is, as I say, this is a relatively new product, so there's only just over a year's worth of data available for this at the moment. In terms of sea ice concentration, we also have what's termed as global products. They, in the sense that they cover both the Arctic and the Antarctic. We have sea ice concentration, edge and drift data. These are coming from EUMETSAT's OSISAF, Ocean Sea Ice Satellite Applications Facility. These are really from 2005, and there's a reprocessed version available. There's also a high-resolution sea ice drift product, which is derived from synthetic aperture radar data, and this is running from 2010. But it's also worth looking elsewhere for the sea ice information within the OSITAC product catalogue. Obviously, you might want to look at closely at the regional, the Arctic, for example, based products. And you can also look in some of the SST products. For example, the Ostia Level 4 product also includes sea ice concentration information. We have Level 3 and Level 4 wind products also. These tend to be derived from scatterometer data, so the wind causes the surface of the ocean to be rough, which changes the backscattering seen by the scatterometer. This is an example of the Level 3 product. You can see that there's gaps in the data. In this case, it's showing each of the orbits, the ascending and descending parts of the orbits are separated out because of the fact that the winds can change a lot during the day, so you don't want to combine the two together. So you can see that's where a lot of the gaps have come from in this particular data set. This is running from 2012. The Level 4 version of this is slightly different to the SST Level 4 product that I showed, which was completely independent of model data. The Level 4 wind product uses combines observations and ECMWF model output to give 6 hourly wind fields. This is running from 2012, and there is a reprocessed version of this one available. So which should you choose? Should you choose the Level 3 or Level 4 wind product? So the Level 3 product has the holes in. They're daily global products, but divided into ascending and descending orbits. And if you're interested in the ECMWF outputs, the Level 3 data does include the ECMWF model outputs at the same time and location as the satellite observation, if you wanted to look at both of them. If you go to the Level 4, then the products have been derived by interpolated filtering and blending with NWP model outputs from ECMWF, and they're 6 hourly products on a quarter-degree grid. So that just briefly outlines the different global products that we produce. So now I just want to focus in on the reprocessed products. So we've got a number of these available. For SST, we have global Ostia daily, monthly and seasonal files. These cover 1985 to 2007. And then there's also regional reprocessed products covering the Med Sea, Black Sea and Baltic Sea. For sea ice, we have global from daily data from OSISAF, plus an Arctic Level 3 ice drift daily reprocessing. And for wind, we have a monthly global data set. So why use reprocessed products rather than near real time? Well, with near real time, what you're getting is you're getting a product that's available up to the present, available often within just a few hours of the data being collected. They are state-of-the-art in the sense that they're using the latest version of the processing system. So you want to use the near real-time version if you're interested in getting the best possible data as soon as possible. But where you probably want to have a bit of caution is if you go and download the old archive of near real-time data and try and use those to look at changes over time. Because the problem with this is there might have been changes in the processing system at various points as upgrades are made, and there might have been changes in the input data that are used. So there could be discontinuities in there. You can get over that mostly with the reprocessed products. They're closely related to their near real-time versions, but they use a consistent processing scheme. They may use different versions of the input data that's a more consistent or more better processed versions. So, for example, the austere reprocessing uses the Pathfinder AVHR data as its input rather than the data that would have been available in near real time. So as there are differences, you probably want to be slightly careful when using near real time and reprocessing together if that's what you want to do. So if there's any doubt, please do get in touch and we can advise. So there's, I'm sure, many applications of these reprocessed products. Ocean and climate monitoring, climatology generation as input to reanalysis, and of course the CMEMS Ocean State Report is a particular example which there's talk about tomorrow. So, just as part of this talk, I'm going to give a couple of examples of the use of long time series of observational data. So the first one is actually something that was done for the Ocean State Report. So we wanted to look at the SST anomalies in 2015. So to do this, we produced a climatology using our reprocessed product and subtracted that from the average of the near real time average data for 2015. And this should be okay to do because of the fact that the signals we're looking at should be larger than the discontinuities when comparing the reprocessing and near real-time data. And some of the features that you see were have also been mentioned in the previous talk. So we can see the El Nino here, and we can also see this cold anomaly that was already discussed. And finally, these are a couple of plots taken from the UMetSat OSCSAF website. As I mentioned earlier, CMEMS provides OSCSAF products through its website under agreement with UMetSat. But it's a good example of the use of a long time series of observations. And on the left here, we can see the sea ice extent, which is defined as the area of sea ice with concentration greater than 15% throughout 2016 in black. And as it comes down to its minimum, you can see it's relatively low compared to the mean over 1981 to 2010, although not quite so low as the minimum in 2012. And then on the right, we have the time series plotted over time, and you can see trends here in both the maximum extent and the minimum extent in each year. So just to wrap up, if you want to get hold of our data, you can do that through the CMEMS online catalogue, and the link's there. There's also a link here for the Python client to automate extraction from the CMEMS catalogue. All our products are in NetCDF format, so here's some links to some NetCDF tools, And if you want to contact us, you can do so through this link here. Thanks for listening.